Friday seminar. I'm Rob Bertini, and this is my colleague Jennifer Dill. We organize this seminar series, and today we're pleased to welcome Francis Reynolds, and he has a very interesting background. He has a mechanical engineering degree from the University of Washington. He's lectured at the UW for many years and worked at Boeing, and one of the projects that he held a management position on was the Morgantown People Mover. And so today Mr. Reynolds is here to talk about the coming dual mode revolution. And thank you very much for coming.
Thank you, Rob. I'm going to have a heck of a lot of slides here and too little time, but we'll do the best we can. The dual mode system that I'm going to be talking about is basically this. We will keep some kind of private vehicles. Maybe we don't call them automobiles because automobiles have a bad name, but let's call them cars. And we cannot take the cars away from the public. They won't stand for it. All attempts to the contrary are going to fail. So what we are proposing, and I say we because in 1980 I invented this system, and then I got on the internet a little later and found that 50 or so other people all over the world have invented essentially the same system. When an idea's time is ripe, you will frequently find that it is co-invented independently over a large area. But what we are talking about is retaining some kind of private vehicles that can be owned or leased or whatever you want, and a combination of the public vehicles and commercial vehicles that we now have, and we will drive them in a manual mode manner on the streets and roads as we currently do. But when we're going to go more than a few miles, we will get on a high-speed automatic guideway with that same vehicle, and the driver will be completely out of the loop there. He can't make any stupid mistakes because he has no control. All of the manual controls on the car will be disconnected at that time. When he gets to his destination, he again gets into the street mode, and he takes over, and he has his own vehicle from the beginning of the trip, from departure point to his final destination. And if he goes across the country, he's still got his car. He doesn't have to rent one. He doesn't have to take taxis, and complete privacy all the way. This is a quotation Kim Golderman is one of the co-inventors of this system. I didn't get acquainted with him until rather recently, but I think he has stated the problem well. I don't know how Portland is set up for light rail, but we in Seattle are trying to put in a light rail system. And this Harvard study, I think, shows the futility of it all. The public gets desperate. Obviously, we've got traffic problems that are not being solved, and we've got environmental problems that aren't being solved. We're running out of petroleum, and we are polluting the atmosphere and causing global warming. So everybody wants to do something, but the things that are being done don't make sense. In the case of light rail, this study showed that most of the light rail systems that have been put in lately are not getting anywhere near the projected ridership, and that they are not taking very many drivers off the roads. What they are doing is taking people out of the bus systems, taking bus riders, and then the bus companies go out of business, but we're spinning our wheels. Meanwhile, we spend millions of dollars on these things and take up more land space. So frankly, the dual mode crowd is, well, frustrated that this money can't be used for something that makes more sense. These guideways, as I think I mentioned before a little bit, are going to accept mostly private vehicles, the same as our present highways take mostly private vehicles. And some dual mode advocates are proposing small guideways and light vehicles that carry 1, 2, or 3 passengers. And they say we can't afford to build a big enough guideway to take anything else. But I say that is penny wise and dollar foolish, that it only makes sense to make guideways that will essentially duplicate what our highways are now doing, what our highways used to do well but are now doing very poorly because they're so badly overcrowded and because of our depletion of petroleum and all of the other related problems. So we're proposing that not only private cars, but buses, trucks, taxis, rental cars, and light truck, light cargo will be carried on the guideways, light freight. And most of the vehicles on the guideways, we are thinking, will be dual mode vehicles that can also operate on the streets. But some will have no use to ever use the streets, so they will be guideway only. They'll be single mode vehicles, such as long distance freight and Greyhound type buses, this type of thing, but all without drivers. And therefore the cost goes down and the safety goes up. Want to save your questions till later? Thanks. In the early days of this system, we will probably use existing automobiles, because that's what we have, and we will put them on some kind of pallets that will then interface with the guideway. These pallets have many disadvantages. It will allow us to use conventional automobiles, but the guideway cost will go up in a palleted system because we have to provide means to return those pallets to the places that need them after the pallet is abandoned by somebody getting off of one. A true dual mode guideway system makes a heck of a lot more sense, and I'm sure that is what we're going to see ultimately. But in the interim, we're going to have pallets, well, pallets first, and then a mixture of pallets and dual mode, and then mostly dual mode, but dual mode vehicles, I should say. But there is always probably going to be some use, some need for pallets for special uses. For instance, if you want to haul your boat to the seashore or across the country, you need a pallet to put it on. A basic dual mode system would let us get on the guideway, go where we want to go, get off, and then look for a parking spot for our car in the usual manner. But it occurred to us that this doesn't make a heck of a lot of sense because the cars can be parked automatically also. If you look on the internet, you find a half a dozen companies selling automatic parking systems that save the driver time and also park a heck of a lot more vehicles in a lot less space because the automatic system can tuck them right together, not worry about room to move them around. With the automatic parking, these would probably be built in hotels and office buildings, theaters, malls, sports arenas, and so forth, like our present parking garages are. And the person who parks his car in one of these facilities would simply get out of the car, and the car would be automatically parked, and the system would somehow give the driver a number to recall his car. When he comes back, he punches in that number or speaks the number and waits a minute or two, and his car automatically appears. He's got valet parking service with no tip required. There are a great number of choices in this game, and those of us that are working on it are arguing which the best choices are. And I'm going to give you my choices as we go along here. But here are a few of the options available. For energy for street mode, we're still stuck with the same things that we are currently talking about as alternatives to petroleum. Batteries, fuel cells, hydrogen internal combustion engines. This liquid nitrogen is an interesting one. There's a research project going on at the University of Washington, or has been, it may be completed by now, where they are running liquid nitrogen through a heat exchanger and then into what is in essence an old-time steam engine. And this is definitely a heat engine, but interestingly enough, the heat is not a furnace under a boiler. The heat is obtained from a heat exchanger, which is taking heat out of the atmosphere. And at first glance, it looks like, gee, maybe we're getting something for nothing. But it is not that, because the energy went into liquefying the nitrogen in the first place, but we didn't have to carry that system in the car. All we have to do is provide a heat exchanger to take the heat back out of the atmosphere to turn the nitrogen back into a gas and expand it. In the Guideway mode, incidentally, I am not a believer in hydrogen or fuel cells. Yes, they work, but their efficiencies are low, and we don't have any hydrogen. You will find websites on the internet that talk about we've got to go to a hydrogen economy because the oceans are full of water, which is 2 parts hydrogen and H2, yeah. And so they give you the impression this is free energy. No way. You put far more energy into decomposing the water into hydrogen and oxygen than you can get out by burning the hydrogen or running it in a fuel cell. So this does not make sense to me until we find a way of making hydrogen in large quantities efficiently and inexpensively. When we get to nuclear fusion, then yes, we may go to a hydrogen economy, unless we can make the fusion reactor small enough to put in the vehicles directly. Okay, in the Guideway mode, we're going to use power grid electricity, and control is going to be completely automatic. There are a number of configurations possible. The cars can be suspended below an overhead guideway. It can ride on top of a raised guideway, and a number of other versions there. The vehicle can be supported in the guideway mode on the same pneumatic tires we use on the roads, on the streets, or it can use steel rails and steel wheels, or you can use an air bearing system or maglev, and I am a strong proponent of maglev for this purposes. Maglev trains, in my opinion, are never going to go very far, not because maglev isn't good, but because the whole concept of coupled trains is obsolete. And putting maglev under it doesn't get rid of the obsolescence of the train concept. But maglev is a natural for dual mode levitation of the vehicles on the guideway. Propulsion, with maglev especially, we can use linear motors, but some advocates want rotary electric motors. I don't like that one at all because you have to build a rotary device, and then you have to have a transmission system, and then you have to depend on the traction of wheels on the guideway. But a linear motor makes a lot more sense, and we'll get into that in a little more detail here. All of these concepts, all of these different propulsion systems and guideways would use all of the acceleration and deceleration in entry ramps and exit ramps, the same as we do on our highways. I'd like to point out that this whole guideway system is an awful lot like the highway system. It didn't occur to me when I first started thinking about the concept, but the more you look, the more parallels you see between a dual mode guideway system and our existing highway system. And every time you run into a problem, or not every time, but frequently, you will see a problem that you don't see a good answer for, and then you realize, hey, we're doing that already on the highway system, and it's working fine. So it's a thing to come back to. I mentioned overhead suspension of the vehicles. This sketch illustrates the problems more than anything else, really. The one nice advantage of a suspended system is that you get these wheels off the ground. They're not touching anything, and we've got a maglev system overhead, and we can guide it, and we can do everything we need to up there. But the big disadvantage is obviously that you've got this structure of some kind built on top of your car. I looked at various ways of retracting it, and conceivably it could be done, but it gets messy and it gets costly. So after studying suspended dual mode cars for a while, I finally gave up, decided it's not a good idea. But there are some colleagues out there that are still proposing this concept. Another related technology here that is probably going to come along a little later than dual mode transportation, and it is a type of dual mode transportation, or can be, is vehicles running in evacuated tubes. Some of you have probably heard of this, read about it. The beauty of that is that we can get the aerodynamic drag down. There's no problem of getting enough power to drive something fast in a vacuum. In fact, as we know from our satellite technology, you get it up to speed by putting power into it, and then in a vacuum it circles the Earth forever. But getting it up there is expensive and dangerous. Our ordinary airlines fly at 40, 50,000 feet, where the density of the air is only a couple of pounds per square inch, and the aerodynamic drag is way down, and that plus better weather is why we fly at those altitudes. But if we put a tube at ground level or underwater or on the surface and evacuate the tube, then we can fly our fly is perhaps not the right word, but using maglev, it's flying. We can put the vehicles inside of this tube, and now the power consumption is way down. We are completely independent of weather, and we are pretty independent of security threats. It's a fascinating system. There is at least one startup company in this country that I know of that is doing a lot of work in this area. And here is an email letter I got from a Swiss outfit that is developing it for use in Switzerland. And those vehicles could be dual mode just as well as any other kind. I am proposing a two-speed dual mode system, 60 miles an hour in and around cities and residential areas on the guideways, and holding it down to that level because at higher levels, the faster you go, the more area, the more bigger the turning radius, and that gets a little difficult in populated areas. So across the country, between cities, I'm proposing 200 miles an hour, and the numbers get interesting there. Seattle to Portland, 52 minutes. Portland to San Francisco, 3 hours. To Los Angeles, just shy of 5 hours. And you'll always have your car when you get there. Oh, and this is a very interesting and important one. Dual mode will reduce domestic air travel. You think of all of the hassles you have to go through at the airports to get on an airplane. You've got to get to the airport and some other means of transportation. You have to find parking. You have to go through security checks and baggage checks and long waits. And taking all of this into account, we're figuring that a 200 mile an hour dual mode guideway can be faster traveling for trips up to at least 1,000 miles an hour than going by air. And not only that, but have you ever thought about what our airline system is going to be when the petroleum's all gone? You get a different estimate on when that is going to be from every expert you talk to, but some pretty qualified people are saying in 10 years our petroleum is essentially going to be gone. And that is scary. How do you fly any airplane, for instance, without petroleum? Extension cords don't work very well. So here is a way that we're going to be able to continue to do the job of the airlines, but do it much better than it's now being done, and we'll be able to continue to do it when we have no more fuel. it occurred to me one day that there's a great difference in how we get something from one place to another. If you carry water in buckets or runs trains and buses and airplanes, these are all low capacity systems because they're intermittent flow. But water pipes and power lines and private automobiles and dual mode guideways are very high capacity because they can be continuous flow.
It strikes me that buses and trains do have stops, and so do private cars. You have stop signs, you have traffic signals, you have traffic congestion on freeways. They stop all the time. So can you talk a little bit about this idea about continuous flow and kind of why they would be in a separate category?
I think we can get into that a little later. It's not continuous flow if you only have a vehicle now and then. But the point is, you can put on the guideways, yeah, we don't have continuous flow on our streets, but our highways, if they worked optimally, would be continuous flow, because you get the best results when everything is going at a constant speed. I think when I was talking about linear motors, I should have made the point that I am strongly in favor of synchronous linear motors. Maybe I'm not to that yet. I'm confused here. Sorry about that. With a synchronous motor system, then all of the vehicles on the guideway will be locked in step with each other, and then you can have continuous flow because they're not going at different speeds. High-low mag, I put that in ink because I wanted to make a point here. When I dreamed up my own dual mode system, I called it high-low mag, standing for high and low speed magnetic system, maglev system. And most of the data I'm going to be presenting in the rest of this presentation are based on the system I would like to see built, but not everyone agrees with me. Okay, in the high-low mag system, one highway lane, well, in any system, in the present system, one highway lane is equivalent to about 27.6 cars per mile, and that works out to 1,660 cars per hour at 60 miles an hour. But one high-low mag guideway at 1 foot clearance, we're going to talk about that some more too, we get 330 cars per mile, or 20,000 cars per hour at 60 miles an hour, 66,000 cars per hour at 200 miles an hour. And the arithmetic there works out to the fact that one guideway lane equals about 12 highway lanes at 60 miles an hour. At 200, we're equivalent to 40 highway lanes. So we build one guideway lane across the country, and it's good, Lord knows how long. You're never going to have 40 highway lanes across the country. But in and around cities, 12 highway lanes is going to be plenty for a while in most areas, but eventually you might add a lane or two. And of further interest here, somehow we've got to find room for the first guideway lanes, and that is tough. But one good approach, I think, is to use median strips between highway lanes, between lanes in opposite directions. And using old railway right-of-ways, using power line right-of-ways. There's lots of options, but it's difficult. But anyway, if we can find the room to make a single, go ahead.
Yeah, the question, at that speed, how will they exit the guideway?
We'll talk about that. Sorry, I lost my train of thought. In most cases, try to hold your questions until we're through, because many of your questions are going to be answered. What was I speaking of last? Does anybody remember?
I think you just finished that slide.
Yeah, okay. And continuing this capacity thing and the continuous flow thought, one highway lane is equal to about 50 full Greyhound buses, and I've forgotten exactly how many people are on a full Greyhound bus, but it's quite a few. Equals one highway lane requires a bus per minute. The private cars on a guideway carrying, I think it's 1.2 passengers per car, is equivalent to about a bus every minute. But when you convert this to the guideway, why, we require very much more than one bus per minute. Well, 10 times that, 12 times that. And with the high-low-mag concept and a 200-mile-an-hour guideway, and only one person per car, we need 186 747 jumbo jets per hour. And so you see that many of our accepted forms of transit are not carrying, cannot carry anywhere near the kind of capacity that we need. And if we put 6 people in that car, we can carry 400,000 passengers an hour, and that could evacuate Atlanta in 1 hour. I picked that because Atlanta had the right population. But converting to Portland, it takes 1 hour and 19 minutes to evacuate Portland with one lane of guideway at 200 miles an hour. In theory, of course, but that really wouldn't be too far off if you have as many entry ramps as we need. So the people from every entry ramp would funnel into their ramps, and they merge and eventually are on the 200-mile-an-hour guideway, and the capacity is enormous. Let's talk about maglev a little bit. This is a toy I have at home. There's a block with strong magnets in it and a top you spin, and the top floats several inches. The block is down here where you can't see it, but it appears to be floating above my hand because the magnetism goes right through the hand. Yeah, this is the foil that I was worrying about. Linear motors are like rotary motors, except they are unrolled. They are linear instead of round. And linear motors can be either of two types, induction or synchronous, like rotary motors. And synchronous motors are the ones I'm voting for because it makes a simpler dual mode system. If you use a non-synchronous system, then you have to have all kinds of sensors to keep track of where the cars are and keep them at the same speed. You've got to have distance separation is a better word, sensors to tell how far ahead the car in front of you is, and then that sensor has to adjust the speed of your car to not go too fast and bump into him, or not go too slow and delay the whole system. But synchronous motors are like plug-in electric clocks. All of your plug-in electric clocks run at exactly the same speed because they're all seeing the same alternating current. And the power system carefully controls that 60 cycles to exactly 60 cycles, so your clocks keep good time. Another way I like to look at it is boxes on a conveyor belt. In essence, the conveyor belt is a synchronous system, and no box ever overtakes another one. None stops and knocks the ones behind it off. They are all synchronized. And that is exactly what the cars on a synchronous dual mode guideway will be, except that instead of being coupled to each other by a physical belt, they're going to be coupled by magnetic wave, and that's just as real. Another interesting point is that these linear synchronous motors, like rotary synchronous motors, will operate as alternators also. So if you have a load on the motor, it doesn't slow down until it completely drops out of phase. It will simply draw more current, and there will be a slight phase shift, but it continues to run. But if you overdrive the motor, if you try to run it faster than it wants to run, the phase shift is in the opposite direction, and it again starts drawing more power, but at a different power factor, I think. So if the power fails, these things keep each other synchronized, and if we're going downhill, any power, any thrust from gravity in excess of the aerodynamic drag and what little magnetic drag there is in the maglev system, any excess energy will generate electricity that'll go back into the line and help people, help cars that are climbing. Okay, I'm talking about 1 foot clearance between cars. That is a guess. There's so many factors in there, I don't think anybody could give a realistic number at this time. Well, and any number you come up with is going to be based on certain assumptions. But the assumptions I made, it looks like 1 foot is a reasonable number. And of course, close spacing is important from the standpoint of system capacity, because the capacity is directly proportional to the speed and inversely proportional to the car spacing. And it's those considerations that led me to the numbers I quoted on system capacity. The other important thing about getting the cars close together is reducing aerodynamic drag. Closely coupled smooth railway trains are a heck of a lot lower drag than running those people in private buses would be, which are widely separated. And you know that bicycle racers, for instance, run closely behind each other to reduce the drag, and a team will run together, and every once in a while the leader will drop back behind so as to rest, because he's been doing more than his share of the work, and they rotate that way and distribute the stress. Okay, the question was asked about how do you get on to and off of this thing, the Guideway. Since the guideways are all going to be constant speed and synchronous, velocity can only change in offline ramps. And when you think about it, that's, again, exactly what we're doing on our highways, or should be doing. You accelerate up to highway speed on the ramp, and then you merge with the existing traffic. And likewise, when you get off the highway, you don't start slowing down on the highway. You pull into the exit ramp at full highway velocity and decelerate down to street velocity. Okay, with these synchronous motors I'm proposing, the question comes, how do you accelerate and decelerate if they got to run at synchronous speed? This isn't too bad, actually, because, well, there's two ways you can do it. You can generate variable frequency, and with modern electronics, this isn't at all difficult to do and is economically feasible. Likewise, you can vary the pole pitch on the Guideway magnet arrangement. And I should mention there, Guideway magnet arrangement is one possibility. The other and if you've got magnets in the guideways, then you have coils in the car. But if you want to put coils in the driveway, then you put magnets in the car. These are interchangeable. In other words, you can look at either side. Well, we build rotary motors that way. Sometimes you have a rotating permanent magnet, and sometimes you have fixed permanent magnets. Okay, also you can vary the frequency in this linear synchronous motor to exactly position a car that is merging with the synchronous guideway. Okay, cars will self-synchronize with power off. If one car has a little more aerodynamic drag than the other, it will attempt to slow down, but when it does, it will simply draw more power from the line because of the phase shift, and the other cars will, well, it depends on whether we got power on or power off here. Yeah, power off, okay. The cars that have less drag will provide power to those that require more power, and the system remains self-synchronous even though there's no power going into the system at that point. And we will need these ramps not only for entering and leaving the guideways. We will need interchange ramps to position cars for transferring from one guideway to another. The merging problem again. Railroad trains switch horribly crudely. They switch by a 19th century method of physically changing the track configuration. And those of you who have ridden trains know that this can be not only a slow process, they have to slow way down, but the train lurches and makes all kinds of bad sounds. Incidentally, I am arguing that the railroad system is obsolete. The concept of trains is obsolete. A good example here is the fact that our rails are 4 foot 8 inches apart, as I recall, the standard gauge. And that was designed, that became a standard about 100 years ago when railroad cars and locomotives were a heck of a lot smaller than what we're using today. And it was a reasonable gauge back then. But it became standard, and now we're putting enormous locomotives and enormous cars on these closely spaced rails, would you believe that the tread on your automobile is bigger than the tread on railway tracks? And we wonder why we have derailings. Okay, in the dual mode system I'm proposing, we will do all of our switching at full velocity, and we won't have the problems that the railroads have, because instead of changing the track configuration to make a car go in a different direction, we will do the steering, the switching from the cars, which again is exactly what we do on the roads and highways. We turn the steering wheel. We move the car. We don't move the highway, because if we did that, then all the cars would have to go in the same direction. But by doing the switching in the cars, then you can do it at full velocity, and you have no influence on any car in front of you or behind you. But this switching in the cars, because of the high velocity of the system and a finite time that's going to be required to do anything mechanically in the car, we have to give it the switching signal some distance ahead of the actual junction. And that has to be about 100 feet ahead at 60 miles an hour and 300 feet ahead at 200 miles an hour, if the switching system is able to operate in 1 second, which I think is a reasonable mechanical requirement. One of the great advantages of this switching in the cars is that we can use maglev for that also. I'll show you a little bit more of that in a moment here. So there's no physical contact, no wear, no noise, and the thing, using the right kind of maglev, it will still be active even though the power in the system fails, so it can't cause any accidents. In inductive maglev, you put no electricity into the system whatsoever. It is relative motion between the vehicle and the guideway that produces the force. This is a little demonstrator toy I made. This is a aluminum disc, a foot in diameter, and a cardboard car, and a horseshoe magnet on it. And when the disc is stationary, the car sits quietly there, and we spin the disc up to speed with an electric motor, and the car lifts off several inches. This is very impressive with a small little car, but we won't need those kind of proportions for an actual system. This system of inductive maglev, and maybe it's worthwhile going through, time goes so fast. But very briefly, what is happening here is that the permanent magnet is putting flux through the aluminum disc, and now when we move the aluminum disc, we are cutting those lines of flux, and we're generating a voltage in the disc and a current which has its own magnetic field, which turns out to be equal and opposite to the magnetic field of the permanent magnet. And so these repel each other, but all of the energy is coming from the motion. Okay, if our dual mode car is lifted by a different type of maglev out here that is combined with the linear synchronous motor parts, then we need some way to keep this on the roadbed, keep it on the guideway, and some way to switch it, to steer it. So we provide 2 guide rails. These need to be electrically conductive, and aluminum would be the cheapest way to go, but copper would be better if it didn't cost so darn much. Then we have a magnet structure, 2 of them, that are in a toggle arrangement so that one is always down and the other is always up. Mechanically, they can never both be down or never both be up. And in this case, the left magnet is engaging the guide rail, so the vehicle is going to follow the left guide rail, which we can get a better picture of here. Okay, here the left magnets are down, engaging the left guide rail, so it's going to go straight ahead. Here's one with the right magnets down, following the right guide rail. As long as we're talking about a straightaway, it doesn't matter which set of magnets are down because it's going straight ahead anyway. But here the right magnets were down, therefore it followed the right rail and exited. And up here we've got the left ones down, so it's following the left rail and exited. This is how we are steering this thing without doing anything physical except toggling those light magnet structures. The linear synchronous motors are going to use about half the fuel consumption and half the carbon dioxide, generate half the carbon dioxide. The obvious question is, compared to what? In this case, I meant compared to an internal combustion automobile. And assuming that we are generating the electricity for the guideways from either natural gas or petroleum, because we can get 60-some% total efficiency out of a modern power plant, and automobiles are lucky to get 15 or so. There is loss in the generation of the electricity and loss in the use of the electricity, but all in all it comes out about 50%. A great advantage of, a number of advantages of using electricity, but a great one in this period of energy problems is the fact that you can make electricity from essentially any source of energy. And we are now looking at a number of alternate sources for electricity, and most of them have bad limitations. You've probably read articles where certain people are complaining about wind power because it makes noise and it kills birds and Lord knows what all. And solar electric panels are very inefficient, and they take a huge amount of area because the amount of solar energy we receive is very dilute. They figure that we are using up all of the Earth's reserves of petroleum in 100 years or thereabouts, and yet it took millions and millions of years to put those reserves in there. But if we think we are going to take the sun's energy and use it on a real-time basis and be happy, we got problems. Okay, this reduction of drag due to cars being close together we talked about. Street mode portable power this is a bad one at the present time because none of these options give us anywhere near the energy per pound that gasoline does. Batteries are in the order of 1/10 the energy per pound of petroleum, and these others are in the same ballpark. But the beauty of the dual mode system is that now, instead of having to put vehicles with these kind of inadequate power supplies on the highways, we only put them on the streets for a very short part of our total travel time and total travel distance. Therefore, all of these become much more reasonable solutions than they are for as alternate power for existing automobiles and existing highway systems. I don't know if anything there is worth talking about much. We need to speed up here. But yeah, we're going to have lots of computers in this system, and we will have lots of duplication so that a computer failure is not going to put things out of business. But when a car wants to get on the Guideway, it stops at the beginning of an entry ramp, and the car is immediately interrogated. There's a chip in every vehicle that has its vital statistics and the vital statistics of the owner. And it also puts the vehicle through automatic tests for everything that is vital to safe operation on the Guideways. And if it doesn't pass the test, the vehicle is shunted off the side and is not allowed on. And also, it will have to be tested in external testing facilities on some established schedule. And if the chip doesn't show that it has met its last comprehensive tests, it's not allowed on the Guideway. Most of us start out thinking, okay, we're going to keep track of the cars on the system with global positioning satellites. Turns out that is a much poorer answer than the old-fashioned concept of dead reckoning. This system is going to know exactly where every car is at every split second because it knows when it left, it knows where it was headed, and it knows well, the whole story, while GPS would be much less precise. Okay, we need to take into consideration how do you maintain this system and how do you isolate a Guideway that is in trouble for one reason or another. Obviously, with a synchronous Guideway system, if one part of that system fails, the most obvious result is that we're going to have one horrendous pileup as traffic continues to flow into it. But the solution is not bad. If, let's assume we have a power failure in one section, and I have come up with something I call the automatic turnaround solution. Well, we'll show you here, I guess. Yeah. Let's assume that the power fails in this section of Guideway, and my brake marks there are intended to show that this section may be a mile long, it may be 10 miles long, anything we want to make it, and maybe several sections failed. But this section that failed would be on one power supply, and we're assuming the parts of the system that did not fail are on a different power supply. Oh, okay, we suddenly don't have any power in this section. And the computer immediately responds to that and activates these loops. Normally, the flow would be straight through in both directions. But with a power supply failure here, or a shutdown for maintenance, these people would now go around this loop and go around this loop, and they're circling back and forth on themselves without power, coasting to a stop, and their spacing is held constant by the synchronous phenomenon we talked about. And these people are not going to crash into this disabled section, because they're going to go around this loop and go back where they came from. And yep, they can go back here, even though there was traffic on there that was going through. It stopped the moment that this traffic was circled back on itself. So the system works and looks like the answer. Curves, I mentioned, is going to take land, and the higher the speed, the more land we're going to require. 60 miles an hour isn't bad. We're used to that because we've got those kind of curves on existing highways. Trains are banked to make the passengers more comfortable going around curves, and also to help keep the trains on the rails. An optimum banking is when the centrifugal force just matches the gravity force to keep the people in the train upright. Airplanes bank at 30 feet or 30 degrees as a normal limit, because passengers that bank steeper than that get awfully worried, especially little old ladies, I guess. But in an emergency, the airplane can bank much steeper than that safely. But if we limit our guideway bank to 30 degrees, then at 200 miles an hour, that takes nearly a mile of turning radius, and that's pretty big. But people will get used to different situations, and I think you could probably get the public to accept a 45-degree bank angle, and that cuts it down to almost half of what we required at a 30-degree bank angle. And at a 45-degree bank, the total G's is only 1.41, and that's not going to worry anybody. It's just the tipping that worries them. Economics. Somebody asked what the system is going to cost, the national system, and I say it's going to cost $1,473,000,000 so many dollars and 23 cents. But that assumes that the Mill Street station in Portland is going to have only 2 entry ramps. If you put in 3, well, then we have to change the figure. You can see that it's ridiculous to try to come up with meaningful answers to a question like this. But for just looking at round numbers, if we say that the power to power the thing and the maintenance costs are 3 cents a mile, and the guideway use fees are 10 cents a mile, and we're only, the system is running at 1/10 capacity, we're generating over $2 million per mile of guideway income. And in my opinion, the way to sell this system is national guideway bonds that sold to anybody that wants to buy them, but mostly it would be the traveling public. They want to solve the darn problem. I don't favor increasing the national debt for it. you are probably more familiar with automated highway systems than you are with dual mode systems. These are some comparisons. They're both dual mode, and the automatic highway system is cheaper because it uses existing highways. But in my mind, this is another case of penny wise and pound foolish, because there are too many disadvantages to the automated highway system. It does use conventional automobiles, but it doesn't solve the fuel depletion problem, or pollution, or global warming, and it's got quite poor capacity because their multiple sensor and velocity control systems are not nearly as precise as two cars locked together on a synchronous guideway are. Therefore, the headways are much greater and the capacity is way down. And because of the complexity of their system, I think it's a much more dangerous system than the kind of dual mode system I've been talking about here. Summary. It is door to door, and it will accommodate all kinds of vehicles, and we can go faster than hell, and we can carry some freight. It doesn't require any new inventions. Existing technologies in a number of areas are going to be adequate. And it seems to solve a great many traffic and environmental problems. We can use power from any energy source, and lots of jobs to build it. Going to pay for itself, and we can't afford not to build it. Bicycles aren't the answer, and present automobiles aren't the answer. You will find proponents of all of these different things, but they're all grasping at straws. We have to do something, so each person comes up with something they think should be done, but I argue that we have to look at the problem as a whole. We have to look broadly, an integrated approach. Okay, dual mode, in my mind, is the answer because it's the only one that anybody's come up with that combines the good features of all of these systems and eliminates most of their bad features. But several years ago, I contacted a senior and well-respected member of Volpe branch of the U.S. DOT trying to promote dual mode. And let me quote a little bit of his response. It is by no means clear that any entity exists with the authority to design and implement a true dual mode or national system, nor that agreement on its nature could ever be reached. Dual mode is a very different notion than the interstate system. It is hard to imagine the process by which a decision could be reached among the many necessary parties to commit to such a major and extensive undertaking. It is hard enough to simply widen a major highway. The mind boggles at just the time and cost of the environmental impact statements. I simply do not think that the right way and environmental approvals for such a network could be obtained even if the funding were available, unquote. Unfortunately, there is a great deal of truth in that statement, but in my mind, it's a realistic statement, but it's also a defeatist system. He's saying, we're stuck, we can't get there, let's quit. But in my mind, we've got to try to do it. Whether we'll succeed or not remains to be seen. How stupid are we? But we're not getting there with the things we're now trying. And we needed this system 20 or 30 years ago, and it's going to take at least 20 years before we could have it now if we started today with all the approvals. And in 20 years, we're going to be in very big trouble in as far as traffic congestion and fuel depletion and global warming. We've got to have it, so we've got to try. One way of getting around some of these problems the Volpe guy talked about is to get a czar with some power behind this, and czars always get in trouble because they're stepping on somebody's toes, but we had a czar in the Manhattan Project to develop the atomic bomb. We had a czar when Jack Kennedy sent us to the moon, and they got things done. We have to be open-minded enough to fairly evaluate new ideas, but not so open that our brains fall out. We don't need to go into detail, but there have been a great number of steps in the development of dual mode as far as it's gone, and a great many since I stopped filling in this chart. And the dual mode proponents I speak of are 3 or 4 dozen people worldwide who invented it without any contact with each other. And all of us agree on most of the fundamentals of the system, but we disagree on the detailed choices. And we agree that it's getting worse all the time and something's got to be done. In addition to the inventors, there are several times as many people who have heard about this and fell in love with it and are working hard to get something started. We have an internet list called Transit Alternatives, and there's 106 of us on that list at the present time, and it is very useful. Here is an internet page from one guy. I picked the closest one to us here. This guy lives in Vancouver, about 10 miles from here, and he has a startup company and is working hard on it. And here is one of the most promising. This is internet information on the PRISM dual mode concept being worked on by Ford Motor Company. I wrote to Ford and Daimler Chrysler and General Motors about 5 years ago and didn't get a satisfactory response out of any of them. But the closer we get to sorry, no more fuel, the more interested these guys are going to become. But the stockholders want money now. They are not interested in spending a lot of money for something in the distant future. But that distant future is getting closer and closer because we're running out of fuel and running out of a lot of other things. Let me quote you something else here. Fulfilling the need for a transportation system that is both economically sound and environmentally efficient requires a new way of looking and solving our transportation problems. The strategy of adding more and more highway capacity neither solves our transportation problems nor meets the broad national vision of efficient integrated transportation system. That was written by Professor Bertini. And he's right. what those of us working in this field are trying to do is get people interested in it and give us some help. Without any public support, we never get off the ground. And the people that should be working in it, the motor companies, the U.S. Department of Transportation, the U.S. Department of Energy, and the investors and all of the other businesses all see some way that this could hurt them. The voters are not interested until they see that the public wants it. And the newspapers are not interested because it's not news. Getting this snowball rolling is just extremely difficult. The Institute of Transportation Engineers, I guess that's what that stands for, are so far not interested. I think they should be, and several other technical organizations, societies should be also. I submitted a dual mode transportation paper to the ITE several years back for a conference on advanced transportation, and my paper was rejected because it didn't fit any of their existing categories. They didn't have a category labeled dual mode because they'd never heard of it. So since they didn't have a dual mode category, there was no sense trying to fit it into the conference. But it's this kind of thinking that we have to get around. And I'm wondering when PSU is going to have Dual Mode 101. There are some handouts at the back of the room, a magazine, Futurist magazine, with an article that I wrote that is more broad than what we've been talking here, and also a handout that shows where you can get further information on the internet, and that magazine. And also there's a brief abstract of what we've talked about here today. And speaking of that internet website, in 1997 they had a total of 31,000 visits. In 2003 they had 946,500 visits. So you can see we're gaining a little ground, but it's too slow. That is it. Thank you very much. Now we're open to questions. Don't forget to use the microphone. Oh, yes, sir.
I have a question about the integration of the on-road and the Guideway systems. I understand pretty much the on-ramp concept. You pull in to the on-ramp, sort of maybe like we have our on-ramps today. People have to wait at lines during high traffic time. But what about the off-ramp locations? You know, an existing highway system, you take the off-ramp and you can usually come to a stop sign or a stoplight, and during heavy traffic times there can be quite a wait to get into the existing road system. At the capacity levels you're talking about, if, let's just say, 50 or 30% of the people were trying to get off at that stop, maybe because there's a stadium or a major attraction at that location, what's the traffic going to be like at the off-ramp?
It is going to be have to be considered and worked, and yes, at a stadium or any dense population area, you're going to have many parallel on-ramps and many parallel off-ramps. And there will probably have to be some rework done of the streets leading to and from those areas. It's like a tree. You fan in from a number of roots into one central trunk, and then you fan out. Yes?
I think people are going to have a hard time accepting the moving so fast and having no control of the vehicle and also being so close to other cars. What do you think about getting onto it?
Yeah, it's a point that's been brought up. I am sure you are right that some people will rebel initially, but how many people were willing to fly initially? And how many people were willing to get on an automobile? Behind a horse was natural, but an automobile was unnatural. Yeah, there are a certain percentage of the population that are going to be afraid of anything new, but I think it's a learning thing, and that most people will get used to it. There are still a few people that refuse to fly, and there may be a few people that will refuse to get on the guideways, but unfortunate for them. The lady in front.
Will people be able to retrofit their cars to go on this, or would they have to purchase a new car? And what kind of user fees would they pay to participate?
Well, if we use the pallet system, they won't have to do anything. And that may be, well, frankly, I don't think we're going to see much pallets, because by the time we can get any guideways to put them on, there's not going to be much gasoline left for conventional cars. And any cars that you now own are going to be junked long before the guideways are built. So the cars will be somewhat different, I think, in the next 10 years in anticipation of the guideways. But it's a little difficult to predict exactly what's going to happen in that area. Next man, black.
Our interstate highway system was built because somebody
Can
saw
you speak up a little bit?
Yeah,
My
our
ears
interstate-
are old.
Yeah, our interstate highway system was built because somebody saw it working somewhere else and then brought the idea over here. In order to get this off the ground, would it be a good option to go someplace where there aren't the political hurdles, like, say, for example, China, and get something like this built, and then have people from the state see it and say, we need one of those as well?
Yes, you've got a point that someplace with a more totalitarian government than we have just may beat us to the punch. Yeah, behind you.
How do you deal with emergency vehicles on the system? Do they get priority? How does that work if you have to move an emergency vehicle or something else that would
On the guideway?
Yes, along the Guideway.
Put the emergency vehicle on the guideway. He's going to get there at the same time everybody else does at 200 miles an hour. And nobody can block his way because it's a single lane and everybody's locked in step. Yeah.
Thanks for coming today and pushing the envelope. Appreciate that. But correct me if I'm wrong, the benefit of the system is to long-distance travel. And can you hear me?
Let me move up so I can hear a little better. I'm 84.
Come on. Correct me if I'm wrong, but the benefit of the system you've proposed is for long-distance travel. And so I had two questions about that. One is, have you talked to any of the national air carriers about the competition that would then exist because it is a long-distance travel benefit? And then the second one is, you said something you didn't want to talk about phasing, and I'm interested in why, because any new technology, any new thing on the market really needs a demo.
Yes, and with this kind of a system, that demonstration prototype setup, if it's a mile long, it doesn't prove much, but if it's 10 miles long, the money is starting to go up, but it'd be much more impressive if it's 50 miles long. But where do you get the money to build it? This is part of the whole problem of how do we get started on this darn thing. I ignored the first part of your questions. Restate that, please.
The first part was because it's a benefit to long-distance travel, have you talked to any of the national air carriers? Because when we were talking here at the Portland region about Seattle to Portland travel on air and train, because those are the only two options besides car, the air carriers basically said, we will try and shut down any attempts for you to speed up the train.
Oh, these are threats from the opposition. Huh? Yeah, there's going to be some, but those threats won't carry much weight if the public gets behind the new system. And I think laws would be made, the public would demand that laws protect the new system. I'm not a politician, I'm just guessing. Behind you.
There's a lot of things here that kind of concern me. I'm kind of thinking about it in terms of neighborhoods. You're talking about 60 miles an hour in residential areas with 100-feet turns. We have 200-foot-long blocks. So if you're talking about a radius that begins 100 feet before the turn, pretty much so we just sort of have to clean out our city, rebuild. I mean, how does it work in a neighborhood? And if in terms of vacuums, how do people get around safely when there are vehicles traveling that closely together at those speeds and that many of them? I mean, you're talking huge volumes. You're talking
Yes.
40 lane, 66,000 vehicles
Yeah.
coming off this being fed into these areas. So how do these get absorbed into places where people can actually live?
Well, you have locked in on my suggested 60 miles an hour, and maybe the kinds of problems you're mentioning show that 60 miles an hour is not reasonable in local areas. Maybe we need a 3-speed system. Maybe we need 20 miles an hour and 60 and 200 or whatever. The system hasn't been designed yet, but you are iterating serious problems that have to be considered and have to be taken care of one way or another. But all design is a system of compromises. We can't have everything we want because it interferes with something else that we want. Yeah.
Yeah, I think the next step and kind of answers some of these questions. I think people would like to see a draft regional or statewide plan to actually see what this would look like on the ground. Have you started doing that, or is anyone working on that so we can see what it's physically going to look like in our cities?
No, I haven't. I retired from Boeing 23 years ago, and someday I hope to get back to retirement, but right now I want to go back to Boeing and rest up. I'm doing this simply because of the interesting technical challenge and because somebody has to do it, the old saying. I started out trying to look at some of the technical requirements myself, started trying to do a preliminary design on the system, and got far enough to convince myself that there were no overwhelming, impossible requirements, that it is all doable with ordinary engineering and a minimum of new thinking in the subject. We just have to put it together from what we have. And that is true of practically all inventions. I have a published book on how to invent profitably and why you probably won't. No, actually, that was the title I wanted, but the publisher didn't think that would sell books. So the title ended up Crackpot or Genius, the complete guide to the uncommon art of inventing. But in there, I point out that it's a difficult game.
On that note, we want to thank Mr. Reynolds very much for coming, and I do encourage you, before we do that, to take a look at Professor Jerry Schneider's website. That the link is shown up there. And also I'll put a plug in for my class next term, Public Transportation Systems. We do talk about dual mode. We talk about all modes of public transportation. So that's Tuesday, Thursday, 6 to 8 p.m. Encourage you to join us. And thank you again for coming.
My pleasure.